Chapter 1, Picturing Distributions with Graphs. In Chapter 1, we cover individuals and variables. Categorical variables will be shown in pie charts and bar graphs. Quantitative variables are shown in histograms. Interpreting histograms and quantitative variables using stem plots and time plots. Statistics. Statistics is the science of data. The first step in dealing with data is to organize your thinking about the data. Individual, an object described by a set of data. The individual here is circled as linear. Variable, characteristic of the individual, such as the name, the horse name, like I said, the breed. When planning a study or simply exploring data from someone else's work, ask yourself these questions. Who? What individuals do the data describe? What? How many and what are the exact definitions of the variables in the data? Where? The context of the data collection is always important. When? See previous point. Why? Were the data collected just to describe those individuals or to represent a larger group? Types of variables. Categorical variables places individuals into one set of several groups or categories. So categorical variables are categories. Like the type of breed is a category. Quantitative variables takes numerical values for which arithmetic operations make sense, usually recorded in a unit of measurement. So the selling price. You could add the selling prices together and that would make sense. Exploratory data analysis. An exploratory data analysis is the process of using statistical tools and ideas to examine data in order to describe their main features. Exploring data. Begin by examining each variable by itself, then move on to study the relationship among the variables. Begin with a graph or graphs, then add numerical summaries of specific aspects of the data. Distribution of a variable. The distribution of a variable tells us what values it takes and how often it takes these values. The values of a categorical variable are labels for the category. The distribution of a categorical variable lists the categories and gives either the count or the percent of the individuals who fall in each category. The distribution of the categorical variable lists the categories and gives the count or percent of individuals who fall into that category. Pie charts show the distribution of a categorical variable as a pie whose slices are sized by the counts or percents for the categories. Bar graphs represent each category as a bar whose heights show the category counts or percents. Here is an example of a distribution for categorical data. there's a total here. We should get 100%, but we have a little extra because of rounding errors. Represented in a pie chart, the 100% can be listed as different wedges, given colors to help identify. So let's try to find the largest one, 14.9%. So other majors. And actually that looks like, education is the wedge that's pulled out there. And at 5% for the education wedge, you can see that the other major wedge is about 3 times as large. So that checks. Pie charts and bar graphs. Oh, sorry, that was just the title. So we saw a pie chart in the last one, and in this picture we're looking at a bar graph. So again, we have on the x-axis we have the category that each individual phone would be, and then we have the percentage of phones that fall into that category as the height of the bars in the bar graph. Note, for bar graphs, percents don't necessarily add to 100. So that's why some data is good to represent in a pie chart and some isn't. So if you can't represent your data as 100%, then don't represent it in a pie chart. Bar graph is better. Quantitative data is not represented in a bar graph. It's represented in a histogram. The distribution of a quantitative variable tells us what value the variable takes on and how often it takes those values. Histogram shows the distribution of a quantitative variable by using bars whose heights represent the number of individuals who take on a value within a particular class. Stem plots. Stem plots separate each observation into a stem and leaf that are then plotted to display the distribution while maintaining the original values of the variable. Histograms. Appropriate for quantitative variables that make many values appropriate for quantitative variables that take many values and or large data sets. Divide the possible values into classes, which are equal widths. Count how many observations fall into each interval. May change the percents. Draw pictures representing the distribution. Bar height are equivalent to the number percent of the observations in each interval. An example of a histogram. Here we have a range of freshman graduation rate, or FGR, and the number of states. And we have ranges, which looks like about 5 per bin or class, 5 per class. Each class is represented by a bar. Interpreting histograms. Examining a histogram. In any graph of data, look for the overall pattern and for striking deviations from that pattern. You can describe the overall pattern by its shape, center, and variability. You will sometimes see variability referred to as spread. An important kind of deviation is an outlier, an individual that falls outside the overall pattern. Describing distributions. A distribution is symmetric if the right and left sides of the graph are approximately mirror images of each other. A distribution is skewed to the right skewed if the right side of the graph containing the half of the observation with larger values is much longer than the left side. It is skewed to the left or left skewed if the left side of the graph is much longer than the right side. So the tail of the distribution on the skewed ones, the tail is pointing in the direction of what we say it is skewed. So there's more data on the right and the tail is pointing to the left in the left skewed image. Stem plots, stem and leaf plots. To make a stem plot, separate each observation into a stem consisting of all but the final rightmost digit and a leaf, the final digit. Stems may have as many digits as needed, but each leaf contains only a single digit. Write the stems in a vertical column with the smallest at the top and draw a vertical line at the right of this column. Be sure to include all the stems needed to span the data, even when some stems have no leaves. Write each leaf in the row to the right of its stem in increasing order out from the stem. If there are very few stems when the data cover only a very small range of values, then we may want to create more stems by splitting the original stems. Example, if all the data values were between 150 and 179, then we may choose to use the following stems: 15, 15, 16, 16, 17, 17, which actually stands for 150, 160, and 170. Leaves 0 through 4 would go on the upper stem, first 15, and leaves 5 through 9 would go on the lower stem, the second 15. Weight data, introductory statistic class. This is the weight of everyone in class. And the way they make the stem and leaves is to then only have the rightmost digit as a leaf and visualize where all of these would fall. Once we see, for example, that there are several 1 beginning numbers, then we organize it. So here we have the 192. We put that 2 in place. A time plot shows behavior over time. Time is always on the horizontal axis, and the variable being measured is on the vertical axis. Look for an overall pattern or trend and deviations from this trend. Connecting the data points by lines may emphasize this trend. Look for patterns that repeat at known regular intervals, seasonal variations. Here we have a time plot. Here we're looking at another time plot between public and private school tuitions.